For a very long time, people have wondered about why things fall. It seems so simple, doesn't it? You drop something, and it goes down. But how it falls was a big mystery. An ancient Greek philosopher named Aristotle had an idea about it. He thought that heavier objects fall faster than lighter ones. This seemed to make sense to everyone. If you drop a big rock and a small feather, the rock hits the ground first. For nearly 2,000 years, most people just accepted this as fact, without ever really putting it to the proper test. It was just one of those things everyone thought they knew. Then, along came an Italian scientist named Galileo Galilei in the 16th century. Galileo was a big fan of testing ideas, not just thinking about them. He questioned Aristotle's theory. The story goes that he went to the top of the Leaning Tower of Pisa. He dropped two balls of different weights at the same time. What did he see? They both hit the ground at almost the exact same moment. This was a huge discovery. It showed that the weight of an object didn't determine how fast it fell. It was a game-changing moment for science, proving that experiments are the best way to uncover the truth. Galileo concluded that all objects, regardless of their mass, fall at the same rate of acceleration. The only reason a feather falls slower than a cannonball is because of air resistance. Air pushes up against the feather more effectively because of its large, flat shape. If you could get rid of the air, they would fall together.
An object is said to be in free fall motion when the only force acting on it is the force of gravity, giving it an acceleration of 9.8 meters per second squared. An object dropped from a certain height with an initial velocity of 0 meters per second will have a final velocity after time t of vf, according to the formula, where g is the acceleration due to gravity. This formula tells us that the velocity will increase in magnitude and is directed towards the center of the Earth when there is no air resistance. When drag is present, it will reach its terminal velocity. Displacement of a free-falling body. We start from the fact that displacement on a straight line is also given by average velocity multiplied by time. We also know the formula for average velocity is. We also know the formula for final velocity as mentioned earlier is equal to. We substitute this to the equation in getting the average velocity and get. We now substitute this expression for average velocity in the formula for displacement and get. The final equation is. We also see that when the initial velocity and initial position is equal to 0, this formula is reduced to. Here you have to determine if the object is above the origin or below the origin. When the object is below the origin, use negative to indicate the direction. Hence you can omit this when doing the calculation and affix it to signify its location with respect to the origin. And time is given by.